We're going to practice factoring by grouping, but before we do that, we're going to take a look at something that looks like this. So if I have the product of A and C, and I'm subtracting the product of B and C, I notice that these two terms have a common factor of C. Since they have a common factor, I can factor out C. So if I factor out C from here, if I have the product of A and C, and I divide by C, all I'm left with is A. And if I have the product of negative B and C, and I factor out C, all I'm left with is minus B. So this is really important to keep in mind when we factor by grouping. So we're going to actually be on page 26 in your packet, and we're going to start with number 2 from page 26. So number 2 says 12a minus 3 minus 2a times a minus 3. So this is number 2 on page 26 in your packet. And this looks very similar to this, the first thing we talked about. So I have two terms, one's here, one's here. This is the product of 12 and a minus 3. And this is the product of negative 2a and a minus 3. So both of these terms have a common factor of a minus 3. So up here, when our two terms had a common factor of c, we saw that we could factor out c, and we were left with a minus b. So here, I'm going to do the same thing. I'm going to factor out my common factor of a minus 3. Now I'm going to look at what I'm left with. For my first term, I have the product of 12 and a minus 3. If I factor out a minus 3, I'm left with 12. And if I have the product of negative 2a and a minus 3, and I factor out a minus 3, I'm left with negative 2a. So this is your final answer for number 2. When you factor, your final answer should be something times something else. The fact that there's a minus sign in here, this is really two separate terms being separated by subtraction, tells me that I'm not done yet. I'm not fully factored until I have something times something else. Let's take a look at number 4. So number 4 on page 26 has 2b squared times b plus 6 minus 3 times b plus 6. So once again, I have two terms, and they have a common factor. So up here, it was really easy to see my common factor was c. And here, my common factor is still simple, it just looks funky. So this is the product of 2b squared and b plus 6. And this term is the product of negative 3 and b plus 6. So their common factor is b plus 6. And when I factor out b plus 6 from this term, I'm left with 2b squared. And when I factor out b plus 6 from this term, I'm left with negative 3. So this is my final answer for number 4. You're not always going to be given something to factor by grouping when it looks like that. It may look something like number 8, and it will probably most often look like number 8. So number 8 is just a 4-term polynomial, okay? Factoring by grouping is very helpful whenever you have a 4-term polynomial like we have here. So I'm going to make 2 groups of 2. So here's my first group, I've got 2 terms. Here's my second group, I've got 2 terms. So I'm going to look at them one grouping at a time. So this is my first grouping, y cubed minus 14y squared. I'm going to ask myself, what's their greatest common factor? And in this case, it's y squared. And I'm going to factor out y squared from this grouping. So this is very similar to what we learned last class, where we just had a normal binomial or maybe a trinomial, and we had to factor out the greatest common factor. That's what we're doing to each of these groupings one at a time. So if I factor out y squared from this, I'll be left with y minus 14. Now I'm going to look at my second grouping. I have y minus 14. Their greatest common factor is positive 1, so I'm going to write plus 1. And when I factor out 1, I'm left with y minus 14. So now I have something where I have two terms and they have a common factor. These are exactly the same, y minus 14 and y minus 14. That allows me to do what I did up here and what we did on problems number 2 and 4. My common factor here is y minus 14, so I'm going to pull that out. And what I'm left with is y squared plus 1. And that is my final answer. So this is the polynomial I started with. This is it fully factored and factored by grouping. I can double check to make sure that this factoring is correct by foiling. And if I were to foil or use the box method to multiply these two polynomials, I should end up with what I started with. We're going to try one that's a little more complicated. It's actually on page 27 in your packet. It's number 15. So number 15 is 2my plus 7x plus 7m plus 2xy. So again, I have a 4-term polynomial, and it doesn't look like this, but I can make it look something like this by grouping and factoring out the greatest common factor. So let me group them. Let me ask myself, well, what's my greatest common factor here in this first grouping? Well, that would just be 1. 2 and 7 don't share any common factors other than 1, and none of the variables are the same. So my greatest common factor is 1, and when I factor it out, I have 2my plus 7x. Now I'm going to look at my next grouping, 7m and 2xy. Well, their greatest common factor is also 1, positive 1, and when I factor that out, I get 7m plus 2xy. Well, now I've got two terms, but what's in the parentheses is not the same. Here I have 2my plus 7x. Here I have 7m plus 2xy. Those are not the same, so I cannot factor anything out. So that tells me that my groupings are wrong. So I need to go back and possibly rearrange my polynomial so that my groupings are more helpful. So now I'm going to ask myself, well, how could I group it? How could I rearrange so that my groups are maybe helpful? Well, here I notice I have 2y and 2y, so they have a common factor that I could work with. And here I've got 7x and 7m. They have 7 in common. So maybe I'll rearrange this as 2my plus 2xy plus 7x plus 7m. And now I'll group it. And this may be more helpful. So I'm going to look at my first grouping, and their greatest common factor is 2y. When I factor out 2y, I'm left with m plus x. Now I'm going to look at my second grouping. Their greatest common factor is 7. Positive 7, so I put plus 7. And what I'm left with when I factor out 7 is x plus m. So now I'm a little bit closer. M plus x, x plus m. Well, they don't look exactly alike, but I know that addition is commutative. So I can rearrange this sum and have it be equivalent to what it is now. So I can rewrite it as 2y, m plus x, plus 7, m plus x. So all I've done from here to here is I've swapped my x and my m, and I can do that because I can do that because addition is commutative. So now I have two terms, and they have a common factor, and that common factor is m plus x. So I can factor out m plus x, and when I factor out m plus x from this term, I'm left with 2y. And when I factor out m plus x from this term, I'm left with positive 7. So the big polynomial that I started with, when I fully factor that, I end up with this. And this is my final answer. And that's factoring by grouping.